We've seen in graph 12.3 that slicing production frontiers horizontally results in maps of isoquants. And we've seen in graph 12.1 that slicing production frontiers vertically, holding one of the inputs fixed, gives us short-run one-input production frontiers. There's a third way that we can slice production frontiers and get something meaningful out of it. This will be a way of slicing production frontiers vertically, but not holding one of the inputs fixed, but rather slicing along a ray from the origin, a ray like the 45-degree line. Suppose, for instance, that the slice along the 45-degree line takes on a concave shape, in other words, a shape that starts out steep and becomes shallower and shallower. Suppose further that the horizontal slices take on the usual shape for isoquants. Along any horizontal slice, our isoquant map then satisfies our usual notion of convexity, the notion that we used in consumer theory when we said that if two bundles result in the same utility, then the average of those bundles will be preferred. Here, the same notion of convexity means that along any horizontal slice, if two input bundles result in the same level of output, then an average input bundle will result in greater output. But there is a second notion of convexity that we can now apply for producer theory. If we connect point A to point B, the entire line that connects A and B lies below the production frontier. In other words, the entire line is contained within the producer choice set that is formed by the production frontier and all the points below the production frontier. Thus, not only are the horizontal slices convex, but the entire production choice set, the three-dimensional filled-in mountain, is convex in the sense that we can take any 2 points in the set, and the line that connects those 2 points will also lie in the set. We can contrast this with a production frontier that, along the 45-degree line, has a convex shape, that is to say, has a shape that starts shallow and becomes steeper as we go along. The horizontal slices of such a production frontier can have exactly the same shape as those in panel A. In other words, the isoquant map that results from such a production frontier can exhibit the same notion of convexity that we've used throughout consumer theory. Take any 2 input bundles that result in the same level of output, and the average input bundle will result in greater output. But when we now connect point A prime to point B prime, the entire line that connects these 2 points lies outside of the producer choice set that's formed by the production frontier and all the points below it. Thus, the producer choice set in panel A is fully convex throughout, whereas the producer choice set in panel B is not. In both panels, the horizontal slices of the producer choice set are fully convex, but only in panel A is the entire producer choice set convex. As we'll see in graph 12.6, this new notion of convexity tells us whether the production frontier exhibits increasing or decreasing returns to scale. For now, just think of it this way. If you're climbing a mountain and it becomes easier and easier to climb as you climb it, then the mountain becomes shallower and shallower as you're climbing it, and the mountain itself is a convex set. But if the mountain you're climbing becomes steeper and steeper and therefore gets harder and harder to climb, then the mountain itself is a non-convex set. Finally, note that we used the 45-degree line here for illustration. We could have drawn this with any ray emanating from the origin, not just the 45-degree line. And in order for our conclusions to hold, in particular in order for the conclusion to hold that in panel A the producer choice set is fully convex, this same shape has to arise along any ray from the origin, not just the 45-degree line.